Hi, I'm Dave Gallagher and welcome to Cineframe Animation's Softimage Character Kit 2. In this video set, we'll look at more advanced character setups. We'll take a look at envelope weighting, texturing and materials for characters, and animation techniques. We'll take a look at some real animation productions to show you some solutions to the different animation challenges you'll face. Let's start. In Character Kit 1, we talked about mostly using NURBS for characters. We talked about the advantages for using NURBS and the other spline formats, B-spline and cardinal. These formats don't crack so much under deformation, they remain smooth. They appear smooth in the interface. Plus they have built-in implicit UV texturing in their structure, which comes in very handy at texturing time. They also have a scalable resolution. You can easily set them to be low resolution while you're working on them, and then render a much higher resolution for a smoother output. We also talked about their disadvantages. You'll remember this character Vigilant from Character Kit 1. Basically, I had to build him in various tube-like structures that were connected together. See, the abdomen is a separate NURBS object, as was the arms through the chest, and the legs. The abdomen was basically laid over, the edges were laid over the other parts. The connection techniques at the time weren't very sophisticated, and it was difficult to keep it together during animation. We didn't really talk about using polygons for high-end characters. Certainly with polygons you can avoid a lot of the hassles of connecting together different NURBS or B-spline parts. Of course, with polygons you're not stuck with a fixed grid structure like the spline formats. Polygons have what's called an arbitrary topology. You can branch off for the arms and legs in areas where you need more or less detail. But although you have topological freedom, polygons are still made up of basically straight lines. And in order to hide that fact and make your character look smooth, you need to use many more points. But characters with lots of points have enormous drawbacks with speed and interactivity. A very high number of points makes point weighting extremely difficult, and envelope interactivity is very slow. Also, large continuous objects like this one are much slower in Softimage than multiple smaller objects that would be collectively just as big. These large continuous objects are much slower in Softimage. Update time slow to a crawl when using a single heavy object. This character on the left would be extremely difficult and slow to animate, whereas the NURBS is manageable. First, in Character Kit 2, we're going to look at some new geometry options that are now available for characters. Advancements that have been made to NURBS and to polygons that help overcome each of these limitations. The first is the introduction of the MetaMesh Extreme plugin from Phoenix Tools. MetaMesh is now part of the Softimage 3D package. The Plus and the Performance pack includes MetaMesh Extreme, but you can also buy it separately directly from Phoenix Tools. MetaMesh is basically subdivision surfaces for Softimage. You start with a low-res mesh, and the software dynamically smooths or subdivides it as many times as you choose. It works something like this. Like NURBS, the resolution is scalable at any time. And you don't have to texture, set up, or animate the smoothed high-res versions. All the weighting info, all the textures, all the UV information, all the animation, and the deformations are automatically transferred from this low-res one to the high-res one at any time. So whenever you dial a resolution like this, up or down, all that information is automatically transferred. But unlike NURBS, you have all the topological freedom that you've always had with polygons. This unusual object that loops in on itself from 3 different directions would be impossible with NURBS, but complex shapes like this with MetaMesh are really a breeze. Subdivision surfaces are really gaining momentum and popularity in 3D applications. Several 3D programs have plugins available that give subdivision surfaces with various capabilities and smoothing types. It's not optimal for all types of modeling, but for organic characters and many applications, it's really a great step forward. Now, to show how this works, if you have the plugin, you can just get a basic polygonal object like a cube, go into Effect, PT MetaMesh Extreme, select the mesh model, And from here you can choose from several options. Most important is the step, that is, how many times to subdivide it, how smooth it will be. 0 is like the original. Most often you might use 2 to 3, and so on. The most useful smoothing algorithm is the quad. While standard is just like Softimage's standard smoothing, quad is a smoother one and works better for most situations. You can also dial the overall roundness, and by the time you see this videotape, Phoenix Tools has scheduled to add in the ability to lock off certain points to make those maintain their hard edge status. In other words, you'll be able to round not just the object as a whole, but each individual vertex. When you click OK, the plugin takes effect, and the original object is actually ghosted so that we can see right through it in the shaded window to the new high-res one. And as we make changes to the low-res one, like I said, the high-res one is automatically updated. Now this continues on into editing of all sorts, like duplicating polygons, scaling polygons, even deleting polygons. As you add or remove edges and vertices, when the MetaMesh object is next updated, you can see the change that takes place. So again, we have a very smooth and even sophisticated shape being controlled by, as you can see, a very few number of points. Now, as with all Softimage custom effects, each one has an icon associated with that effect. And you can see in the schematic window, it's connected by this yellow line. It's often easier in complex scenes to select the icon in the schematic window. To edit the effect, go into Info, Custom Effect, or the more traditional Effect, Custom Edit Parameters. Info Custom Effect is handy because it's accessible from all the modules. And again, you can change all the parameters, even animate the parameters below. Also note that you can access those parameters through their function curves. So if we go into Motion module, we can choose F-curve select, custom, PT MetaMesh Extreme, step. And then if we zoom out here, simply by moving the function curve up and down, we can change the resolution of the object. This becomes handy later when you have a very complex scene. You can grab all the icons at once and change all the resolutions at once. The nice thing about MetaMesh is even when a scene is completely done, for instance, this polygon character has a test animation to test its vertex weighting and shape animations. But even though it's already been enveloped and textured and all that, you can apply MetaMesh at any stage. For instance, even now, we can take this blockiness and fix that by just applying MetaMesh. We'll apply it just like before. Use the quad method, and now we have a smoothed MetaMesh version. And like I said before, all that information will just be transferred automatically onto the higher res version. So it's valuable from that standpoint that you can apply it at any stage throughout your production. Later on, I'll show you MetaMesh being used in production on the superhero character Vigilant. Turns out MetaMesh does pretty well, has certain drawbacks that I'll show you later, but overall is an extremely powerful plugin. It's really a fantastic plugin that can change the way you work in Softimage. In fact, subdivision surfaces is being planned for inclusion within the program, within Softimage in a future version. Technologies like subdivision surfaces really represent the future of modeling. That is, smooth surfaces that can have arbitrary topologies, ones which you can have complete control over and are easy to animate. But the future isn't here yet. MetaMesh, although a powerful plugin, is still just a plugin, which means every time you want to change resolution, you have to go through the special plugin interface, which isn't as convenient as the interface items for the features already included in the base program. It also means you may have trouble with compatibility with other studios. There are also certain speed disadvantages. For instance, this mesh here is easy to manipulate in shaded mode, but when you get a poly mesh that's this complicated, it actually slows down quite a bit, and more than it would if it were that same complexity but consisting of different NURBS patches. So there's certain lags you need to deal with. In addition, you lose things like displacement mapping and surface deformations that are particular to NURBS and patch formats. So a character of this complexity becomes very slow. See, if I drag, there are long lags because of the density of the character mesh. In addition, in wireframe mode, although it's quite a bit faster in update, as you'll see, still means that you have to look at all these points when you've subdivided the surface. And even though that you can swap this back to the original mesh, rather than a smooth looking wireframe, you have a blocky looking wireframe. You may find that MetaMesh is useful in certain situations, but not in others. But in any case, MetaMesh certainly doesn't supplant or replace all the other formats, for instance NURBS. NURBS are really the tried and true format in Softimage, along with the other spline formats, B-spline and Cardinal. But NURBS have been proven in many productions to be a valuable geometry type for characters. They're clean, as you can see here. They're clean in the interface, and they're also easily managed through the interface. They're most commonly used for characters, and if you use NURBS, you can easily integrate with other studios that also use NURBS. And of course, NURBS are built into the software, so you don't have the limitations of working through a plugin to get to your geometry type. Since Character Kit 1, a few advancements have been made in NURBS, mostly to connecting them together. UV texturing on NURBS objects most of the time is very beneficial, but in some cases it's not. For instance, this really should be lined up, projected straight from the front, not flowing with the NURBS. But in Softimage 3.7, which was shown in Character Kit 1, you couldn't use projection textures on NURBS because in an envelope they would slide. The texture wouldn't stick to the geometry when it was deformed. But in the new version, you can use a normal projection texture, align it to your satisfaction, and during deformation, the texture will stick. So that NURBS texturing problem has been fixed, luckily. Unfortunately, one thing that hasn't been improved is NURBS blending. No big improvements have been made in surface blending since Softimage 3.7. Although I was able to get a better connection here by increasing the U step all the way up to 9. But still, the blending effect doesn't quite deliver when it comes to making perfect seamless blends. Two plugins have also come out dealing with NURBS connections. The first is Real-Time Healing from Imageware. This came out just before Character Kit 1 was released, but at that time was very expensive and was very new. But at the time of this recording, it's very affordable, about $500, and it's been proven in several productions, including with the lizards in Godzilla. Real-Time Healing works along the edges only of NURBS objects. Adjacent NURBS objects are sealed together during each frame of the animation as it's deformed. The plugin goes in and maintains tangency between each of the surfaces. It doesn't work, however, on trimmed holes, only on true edges. So that requires that you divide up or slice up your NURBS objects in ways that you normally wouldn't. For instance, if you look at this hand, you can see that where the fingers branch off, the separate surfaces are required in the branching areas. The goal is to get the intersection of the surfaces in those areas where you want to branch. So the hand is obviously a worst case scenario since you have so many parts branching off at the same place. That requires the hand to be sliced up into all these numerous parts. The drawbacks to this should be obvious. Once you've sliced it up, it's difficult to go back and then modify them and keep the surfaces roughly together so that the Real-Time Healing plugin can still do its job. It's also very difficult to texture. Since all these objects are separate, you have to have one texture for each one of these. It's also rather slow. The effect is slow, which doesn't matter as much since you can turn it off when you're animating and only turn it on when you're rendering. The advantage is that now you have NURBS that stay together during deformation, and also have the ability to have implicit UV textures. It's also become sort of an industry standard in film to cut up NURBS this way and to attach them along edges. Models for film also tend by nature just to be difficult and unwieldy because of the number of points involved. The upside of that, of course, is that they'll be able to withstand close-ups at high resolution. The good news is that this real-time healing technology from Imageware has been licensed by Softimage for inclusion in future versions of Softimage. But as for now, a preliminary beta sort of version has come out, tentatively called NCF, NURBS Continuity Fix, that you can download from their website. If I just preview this scene here, you can see a split in the hand area, right in this area here. I've split open just a few of these, dragged just a few of these points to make this split open just a tad. Now if I select the whole thing, choose Deformation NCF, and we can see how it seams itself together. Just render that again. And you can see that it looks seamless now. This stays together throughout deformation. As I drag the points, you see that the other points update to stay continuous. The other plugin is Quick Blend, which was developed here at Cineframe. Quick Blend takes a very different approach than aligning the edges of objects to each other. Mostly is designed to take a tubular object and attach it onto a base object. So in this case, we have a hand and 5 digits coming off of the hand. The fingers aren't attached to any edge or hole in the hand. They're merely laid over the hand geometry. The surface continues on underneath. One of the advantages to this approach over the real-time healing is that you have far fewer objects to deal with. So for instance, in the schematic view, this is the Quick Blend hand, and this is the real-time healing hand. You can see that there are many, many more objects which make it up, and therefore adds a level of complexity which you might not want to deal with, but like mentioned before, can bring you very good results. To find out how many objects exactly we have selected, we can just multi-select all the real-time healing ones, go into the spreadsheet, and click on Queries Selection. All the selected objects come up, and we see that we have 59 of them. Quick Blend offers several time conveniences. The calculations perform very quickly, so even if you have lots in your scene, it's still going to react very well. In addition, since on the Quick Blend hand, each finger and the hand itself is one continuous tube, it's easier to go in and select a row in U, for instance, for things like point weighting. While with the real-time healing hand, because of the many surfaces that make its circumference, it's going to be harder. You'll have to select each one and then go select each row of points. It's also pretty quick to apply. You may recall in Character Kit 1 we used this scene to apply the ear using things like relational zip surfaces. Well, here's how easy it is to apply Quick Blend. We'll just move this ear into place a little bit closer, and then I'll select Surface, Quick Blend, select the head, which is the base object, to Quick Blend 2, and then we'll select the blend object. The Quick Blend dialog comes up, and the first section deals with which edge we want to stick onto the base object. Top view and bottom view are inaccessible because they're closed off, but the bottom V and the top V, we can choose between those two. The purple in the wireframe mode, the purple highlights the edge that we choose. We can choose both top and bottom, but in this case we just want the bottom. But you can always change this parameter if you hit OK and then it turns out to be wrong. This is the number of rows that you want to attach. Most of the time you want to do 2, 3, or 4. 1 won't give you a smooth connection, just a basic connection. This is the number of rows that will get stuck onto the base object. Oversampling most of the time can be left to the default value, but if you're quick blending to an object which has very few points, then you can raise this value up, and that will increase the accuracy when the points from the blend object try to find the best location on the base object. We'll leave the rest of the default values and click OK. When you first exit the dialog box, the Quick Blend icon will be selected, and that's so you can quickly jump back in using Info Custom Effect and make a quick change. If you look at the ear, you can see that the points now lie exactly on the surface, but that the surface itself of the ear is sinking below. To fix that, we need to jump back in and use the offset parameter to raise those ever so slightly off the surface of the head. When you have a Quick Blend object that has very few points around it, like this ear, you'll have to use a bigger number here. As well, this model is very big, so we'll have to increase it much higher than I would normally use. You want it to sink not below and not far above, but raise it just off the surface. With a value of about 0.3, we've gotten some of it to look good, but in other areas, the ear clearly dips below the surface of the head. What's happened is that we simply haven't given Quick Blend enough points to work with to make a seamless connection from the ear to the head. So what we need to do is simply add a little bit of geometry to the top and to the bottom. We'll go back into Info Custom Effect, and here we'll turn on Freeze Points if effect deleted. Click OK. Now we'll delete the icon, and rather than jumping back, the ear will freeze in its quick blended position. Now we can add the needed detail. Now using Edit, Add Point, or Effect Subdivision, I'm going to come in here and add some detail so we can get a better fit. Once that's completed, I'll reapply Quick Blend just like before. Now you can see we have a better connection. For Quick Blend to work best, in most cases you'll want to have an even amount of space between each of the points. You'd want to evenly distribute these in most cases. So in these areas that have wider gaps, we could go in and add points and we get a better connection. Quick Blend can also be used to attach both ends of an object to two different objects in Softimage. So if I hide this, you can see that these are two NURBS objects, and that the abdomen is going in between the two. We'll attach both the top and the bottom ends to the different objects. First of all, I've added some rows and moved the points away a little bit to show how those will attach. I'm going to hide the original, Surface, Quick Blend, and leave it all at the default. First I see that I've chosen the wrong edge. Since it wasn't in wireframe mode, I couldn't necessarily see which edge it was choosing. I'll go back into the dialog with Info Custom Effect, switch it to the top V. At this point the dialog is interactive with the display, so as I move the offset up or down, we can see the change that takes place. In this case, I'll just leave that at 0.01. I'll try 2 rows and try 3 rows to see which gives the better fit. Next, I'll attach the bottom part to the legs. If we turn off unselected highlights, we can get a better look at the connection that it made. Quick Blend will keep these surfaces together through every frame of animation. So for instance, if I move the abdomen, you can see that the points stick on to the base surfaces. Now I've created a quick skeleton inside of Vigilant, and I'm going to use Skin Global Envelope and select the chains. Now since I haven't made any arm joints, I'm just going to select all these points and attach those directly to this joint right here using Skin, Envelope Assignment, Reassign Manually. I'm going to stick them all on that joint. I'm going to make sure all the legs are attached to the pelvis joint. Now when I rotate the first abdomen joint, Quick Blend will keep the points on the base surface and maintain a seamless look. Since polygons have more recently become a viable format for high-end characters and high-resolution characters, I've included this section on polygon character modeling. Now there's MetaMesh, like we discussed, which allows you to use a low-resolution polygon mesh and render a higher resolution one. But now in Softimage 3.8, thanks to some new vertex weighting tools, we can get a similar effect using Softimage's own native toolset. The new weighting tools allow you to use a lower res one while you're modeling and animating, and then interpolating all their vertex weighting onto the higher res one, which you can create either by smoothing or rounding the lower res one, or by modeling a new one entirely. The vertex weighting tools transfer those weights so that you don't have to redo that work, and I'll show the use of these tools later on. You approach polygon modeling differently than NURBS. It's not about coming up with a grand scheme to fit NURBS together in spite of its tube-like structure. With polygons, it's about efficiency and overall the form. Good polygonal layouts track the form of the object, highlighting each shape. Only the points needed to make the shape are used. In many cases, it means that the geometry serves the form rather than the opposite. One of the main concepts in polygonal modeling is the idea of the bevel. If we render just this cube, it looks lifeless and boring. But if we give it some edges, something to actually highlight, then it can take some shape. We'll just use Effect, Bevel. Every polygon in the object has been beveled. So now if we render, you see it starts to look more realistic because the highlights can actually catch the shapes. So sharper shapes are beveled, like the lips here, because you want to make a tight highlight there. But also areas where you just want to highlight the form, for instance, the edge of this nose here. This could be considered a bevel, this edging row of polygons. On the eye here, there's 2 rows of polygons, and that's sometimes called coplanar. It's a double bevel. Also along the ear, the bevel where the sharp edge of the ear comes around. The problem is that Softimage's beveling tool is flawed. We can use it successfully on whole objects like we showed before, but what if we wanted to use it on just part of the object? Say, this polygon's worth of vertices. I'll just switch to tag mode, do Effect Bevel. Well, then we get 2 lines up here going to this one vertex down here, where what you might expect is that this polygon would bevel up itself and leave the rest of it alone. The same effect occurs when we want to do an edge, one of the edges defining one of the areas on the polygon object. So if I select this one polygon and duplicate it, move it up, then I want to select all those vertices and bevel those. The same thing happens. It's not the effect we want. What should happen is that shouldn't create 4 vertices in each place, but rather 2, and only bevel it around the circumference. So if you wanted to bevel this area along the edge of the cheek and make it look something like this over here, you could try to select these vertices and bevel them. But Softimage's beveling tool would give you a result like this. It would quadruple the points where there was 1 and double the lines going from those points to the adjacent ones. And the shading result is not what you're after. The problem is that there are no edge definitions in Softimage. There really is no edge as an entity. We can't select the edge, so we can only tag the points that make up the edge, or we can select the polygon. Even though you can create a new edge between 2 points, it doesn't actually make an edge. It splits the polygon into 2 polygons. You're just actually making a new polygon. In Softimage, bevels have to be done by hand. So for instance, to bevel this area, we'll go to Wireframe, and I've set up that virtual slider that I talked about in Character Kit 1 to block off the back portion. And now we can use the Polygon Vertex tool and create new vertices along the bevel region. Then I can use Polygon Edge to connect them. Middle mouse button, like so. Softimage won't let you create these new vertices in the shaded mode. If I click on Vertex, it won't create them. Only with the middle mouse button, Add Middle Vertex, will it work. But in this case I wanted them up close, so I had to switch to wireframe mode. While Softimage isn't overly competent as a polygonal modeler, It is very responsive and very interactive, so creating that bevel actually goes pretty quickly. Using hotkeys now to access polygon vertex and polygon edge, we can make new vertices, we can take vertices away, and we can create new edges very quickly. Another possible solution is to use another program when you want to do lots of bevels. This is Nendo from Nietzscheman, and they also make Nietzscheman Modeler, which is used to be known as Symbolics, and it's one of the oldest polygon modelers out there. It has very powerful edging features. You can use the import feature to import data that has been exported from Softimage via the OBJ format. We can zoom in right here and select all these edges. Notice we have actual edge selection in Nietzscheman or Nendo. Then right click, use the beveling tool. This beveling is interactive so that you can just drag and determine visually the amount of bevel that you want. Nendo is also good at dissolving or collapsing edges. So if I select these again that we just created, I can either dissolve them so that they all disappear and that creates one big polygon, or if I undo that, I need to select them again, and I can collapse them back sort of the way it was before. So some people use other programs in conjunction with Softimage's polygon modeler to get the job done. Collapsing vertices like that in Softimage isn't automatic. It's a bit trickier, but it's still not that hard to do. There are two ways to do it. One way is to go to polygon edge and just begin deleting the edge you don't want. Then afterwards going to polygon vertex and deleting the vertices you don't want. So that goes pretty quickly. The second way is to go into the layout window and turn on magnet on point all visible objects. Then just by using the M key, I'll just stick the ones we don't want onto the other vertices. When I'm done, I can go into Effect, Cleanup, and choose Merge Near Points if distance less than, leave it at the default, and Merge Unconnected Vertices. Now if we turn off Magnet on Point and use the Move Point, we see that those vertices have all been collapsed. This works pretty well, but every once in a while it can give you troubles if you magnet more than 2 points together. Now the example I showed with beveling was limited to a small area, and that's actually just as easy to do in Softimage, if not quite as precise as with Nendo or another program. But when it becomes difficult and more time-consuming is when the polygon object is very long and very wide, and the edge travels over a long area, and you find yourself zooming in and out to select the right point. Future versions of Softimage will include true edges as entities, and you will be able to select them and manipulate them as edges. So look for that in Sumatra. The next big concept in polygon modeling is the idea of planarity. Vertices of a polygon should normally reside on a single plane. So for instance, this polygon right here is non-planar, as you can well see. It has 1, 2, 3 vertices on this plane, and the other vertex is off. Let's zoom into that by selecting the polygon and doing Camera, Frame Polygon. We can look at it up close and see how it's non-planar. This means that it won't shade as well. This is why some programs resort to using triangles at all times, because triangles by definition are always planar, and so you never have any shading problems. But it's a lot less convenient to use only 3 points per polygon. So for this one, you generally want to avoid that by moving the vertices so that they're closer to being planar. There's also a plugin in Softimage, Polygon, Select Polygon, and you can turn on non-planar, and it will highlight all the polygons that it considers non-planar outside of a certain threshold. And of course it selected the one that we looked at. I designed this polygon head, however, to only be used in its subdivided state, like with MetaMesh. So if I use a rounding plugin on it, you can see that all the polygons are now more or less planar. The process of smoothing resolves all the non-planarity issues, so you don't have to worry about that so much as before. Polygons with 5 points often don't shade well either. This polygon right here has 5 points, and they're not quite planar, so the software actually internally divides it up So it's drawn an edge in between this point and this point, even though we can't see it. Internally it will render that way. This is considered bad form. It's considered better form to decide yourself which way to cut, and you'll see that it's shaded just a little bit better. Up here is a better example of something that doesn't shade well, of a polygon that has 5 points that ought to be probably subdivided. You can see that this has a funny look about its shading, and that's because it's not quite planar, and if we divide this ourselves, let's see it shades just a little bit nicer. Again, if you're going to be using metamesh or some other subdivision method, then you don't have to worry about those 5-point polygons quite as much. What you do have to worry about still is rippling areas and areas with general bad layouts. For instance, this back here is kind of a mess around this area, and the reason is because this was originally converted from NURBS, the ear, and the connection was never quite cleaned up. And so I'm going to do that now. You can tell it's a mess because there's no cohesive flow or design to the polygons. They just sort of jumble around, and that makes for poor shading even when metamesh is applied. Let me do that with Effect, Metamesh Extreme. I'm just going to hide the control mesh so you can see how that's become kind of rippling and ugly. And when I want to get the low-res metamesh object back, then I'm going to hit R for refresh and it'll pop back. Now I could just lower the step of the metamesh object to get that back to its original, but instead I'm just going to delete it for now. Begin working on the lower res one again. I'm going to bring up the back plane so that I don't accidentally delete any edges or vertices in the back. And I'm just going to kind of come up with a new scheme to reorder this. That should work a little bit better. So now I've reapplied metamesh. You can see it isn't quite the mess it was before. The layout looks much cleaner. So now I've reapplied metamesh, and I'm going to hide the low-res object, and you can get an idea of how it's supposed to look when it's done. One of the hallmarks of a good polygon modeler is the ability to get in there and do point-by-point, vertex-by-vertex editing very quickly. And Softimage actually scores pretty high on this account, as we've seen. You can get in there, you can do the work very quickly. Softimage lets you work with data sets in a free way. It'll read in just about anything, it'll render just about anything. The downside to this is it also lets you create and continue working with corrupt data. Softimage lets you work without much supervision, you might say, when it comes to editing polygon objects. So if you don't know what to look for, you can start to get corruptions in your models, and if you don't solve them soon enough, then they can become real big problems. One of the things you always want to do is work with Show Edge Flags On. This will show areas where there are no polygons, where there are open holes. So we know there's one under here. This has no polygons, and we know there's some around the eye and in the ear. But also, over the course of modeling your options, over numerous modeling operations you can do, green lines can start to appear in your object, such as this. All this means is that there's actually a hole here, even though it looks like there's no hole. And if you didn't have edge flags on, you wouldn't know that. If you just move with the mouse, you can see that there is indeed actually an open hole here. If you do Effect Order to try and fix it, the problem will actually spread. You see the green lines have actually tried to fix the problem, and in the process they've made it worse, splitting the green lines further along your model. If you continue doing effect order, this will continue happening. So if I undo that, we can get back to that one state. How to fix the green lines? One way you can fix them is go into magnet on point, make sure the 2 points are together, and then you can go in and do Effect, Cleanup, Merge, and Merge, just like we did before. This most of the times will solve a lot of those green line problems. If you have some question about whether it's fixed or not, sometimes it's smart to go into Effect Order and run it again just to see if those green lines reappear. Now I want to do undo again and get those back. But sometimes Effect Order does not fix the problem, so you have to go in and do drastic things like deleting regions of polygons. So in this case, let me just block off the back there. In this case, one thing we might choose to do is select a polygon and delete it, and then simply remake it. You remake it by doing Polygon, Polygon, and then selecting in a counterclockwise order the vertices. When I'm done, I'll hit middle mouse button, and our problem is solved. Another tool for fixing the holes in the characters is Polygon Weld. If we leave it at the default value, the threshold isn't going to be high enough. We click on the object, it'll create a new one, but since the points were so close together, it welded too much together. We can delete that object and try again, this time using a lower value. And this time it did a better job. One of the drawbacks is that it actually creates a separate object, which is sort of a drawback if you have certain effects working on the first object already. The other drawback is that sometimes weld can give you as many problems as it solves. So use Polygon Weld with caution. Other types of corruption can be even harder to fix. For instance, sometimes you'll get this strange situation where a polygon or more will reach across to the other side of the object and wind up in this strange configuration where you can't select it, and it's very difficult to clean up. Another thing that can happen is when you create new vertices or try to create edges in between those vertices, they won't get created. Also, you may encounter strange lags. As I drag these points here, you'll see that there's a very long lag in between the time that I can let go of one point and drag the next one. If I try to drag the next one before, it just gets confused. This can happen sometimes when you have a large polygon object and you merge them together. It can slow down considerably like this. Also, if it has multiple materials and UV information, it can get very slow. One way to solve this and the two previous corruption problems is to actually save it out and read it back in. Or even more effective is to save it out to a different format and read it back in. For instance, if you go to Tools, Export, Object, Wavefront, now if we import it immediately back in, we can move our model up a bit. Try that again. You'll see that the lag is gone. So exporting to a format external to Softimage, such as Wavefront, and then importing it right back in can be a great way of cleaning up certain types of corruptions like the ones we just showed. Using parts from other characters is easy with polygons. With NURBS, you have to make sure that things have basically the same number of points and the same layout even. But with polygons, it's much easier. You can just add it on very quickly. There are a couple of ways to do this. First, we'll use Merge. Select both the polygon objects, then use Effect, Merge, and don't use any of the options. Click OK, and then you'll get a new object. It'll look just the same, but in the schematic window, you'll see that you have one object instead of two. They're joined, but there's still a gap in between them. In order to fill that gap, we can go in close and start adding polygons. For instance, let me just move the far plane up a little bit there. I'll just use Polygon, Polygon to begin building the new polygons in between, in a counterclockwise fashion. Middle mouse button creates the new polygon. Of course, you can always clean up the connection later. We just want to get them together. From here we can go back and use polygon edge to clean up any of the edges. Again, it really helps to clip the backside using the far plane so that you don't delete any of the edges in the background. In areas like this, we may choose to add a new vertex and join these like that to make it make a smoother connection. We may want to do the opposite here. Create new vertices up there and join this so the connection area is a little smoother. Traveling up here will allow me to define the tendons in the wrist area. And we can make that connection very quickly. So that method works great. Just use Effect, Merge, and then build the edging polygons by yourself by hand. The second method is a little bit more automated. We can use polygon stitch. What we do is simply tag all the edge vertices on both sides, make sure they're all tagged. With NURBS, it's easier to select an edging row because they're always a row in U or V, and you can use the tag points row in U and V commands. With polygons, it's a little trickier because of the irregular format. There's a new plugin from Phoenix Tools, available also in the Softimage 3D Plus package, where you can select a single polygon and do polygon UV select. From there you can choose which direction, and it will try to find a row of polygons. Now we have polygons selected and not tagged points, but we can easily select both rows with tag polygons. Now we have the trouble of going in and unselecting the second row, but this can be very useful in some circumstances. Now when you're sure that they're all selected, simply do polygon stitch, set the defaults, click the left side and then the right side. It triangulates the result along the stitch area, but we can just go in with edge and delete the edges that we don't want. Once I'm done, I'll just copy the material from the old object onto the new one. So we can quickly add on a hand from another character onto a new one. Stitch can also be used on a single object. If you click it twice, then you can close up areas, for instance, in between the shirt and the arm. This is a single merged object, but it's going to be hard to select the points. One of the things you can do, other than just pulling all the points apart, would be to go into Edit, Proportional Setup. Crank this number up to something like 100 or 1000. And then click to Exponential 2 format, and then bow this up like so. Now we need to click on Consider Neighborhood, and that'll make sure that when we drag a point on the arm, it simply detaches from the shirt object there. But if we were to then select some points and then try to do undo to get it back in position, then of course the points get unselected as well. So one thing you can do is use an animation. I'll go to frame 1, go to Motion, Save Key, Object, Shape, and then when we pull those apart, we'll save another keyframe somewhere else. We'll just save that there, and now we can simply scroll in between. At any point now we can more easily see the edge, since the points aren't all grouped together. And that was a whole lot easier selecting them in this form than it would have been if I had tried it like this. If I want to keep this selection set now, I can always go to Tag, Set Cluster, and give it a name. Now to get the animation off, we'll simply go back to frame 0 and F-curve reset object shape. Now I'm free to do things like polygon stitch if I like. Click that twice and it stitches them all together. One final word about polygons. Because of their fluid nature, it makes them easier to model from scratch. This had started from a very simple set of points and was just slowly added onto. And it would have been almost as easy to start from a cube and just begin to cut it. I mention this because I often get asked whether a model was made by hand in the computer or digitized from a clay sculpture. But in reality, it makes less of a difference since it's all sculpting, and polygons just make it a little bit easier to do from scratch. First, in the material section, we're going to talk about a few properties of polygons and NURBS that are unique to each. First of all, if we turn on Show Normals, you can see how each polygon has a normal coming out of each corner. There's actually 4 there, but they're all lined up, and it gives the appearance of each adjacent polygon being smooth with the next one. So we have a smooth appearing hand. If, however, we go into Info Selection and crank this number down, the automatic discontinuity down to something like 20, some of the vertex normals will split into 2, like right here. And down even further, like 5, we'll see lots and lots of normals have split apart, and now we have the appearance of a faceted hand. Polygons are unique this way to be able to do this, and it comes in handy at certain times. For instance, you probably wouldn't want this whole hand to look faceted, but you may want certain parts of it to. You might want a faceted edge right along the thumbnail here. In order to do that, you could pull these points back like this to an angle that was greater than the one we just set, and now we could create a hard edge, a faceted edge along there. You also have the ability to tell any given edge on a polygon object to be faceted. If we go into Edge Flag Discontinuity, we can simply select edges that we want to be faceted. Now you can see the edges become faceted or hard. Another thing that's particular to polygons is the ability to have more than one material on an object. With polygons, you can select a group of polygons, go into Polygon Assign New Material, and give just that group of polygons a new material. It's a capability that comes in very handy at times, and it's difficult to mimic or duplicate with textures alone. With NURBS or B-splines, but not polygons, you can use a displacement map instead of a bump map to give that extra edge of realism. Unlike a bump map, displacement map actually moves the points of the geometry out or in from the surface. Softimage will displace the points that you give it, but just the step alone will probably not be enough. The results will look blocky and stair-step like this. So instead you can go into the render setup and turn on the spatial surface approximation or curvature. Curvature is based on the curve of the surface. Spatial is based on the units. In this case, every 5 pixels, it will add geometry if it needs to based on the contents of the texture map. The surface approximation will subdivide it to be many more times 24,552 triangles shown here. A displacement map texture is applied just like a bump map. The blending is set all the way up, ambient off, diffuse off, specular off. The roughness set up, but in the case of the displacement map, the roughness has to be much, much lower. In this case, we'll use a 0.003. Displacement map check turns on the displacement feature, and of course, it's only available for mental ray. The texture map itself needs to be a little bit different from a standard bump map. With a standard bump map, you can start off with a mid-range gray and go darker for one direction and lighter for the other direction. But for a displacement map, you need to start it with black and go brighter for the areas you want it to displace out or displace in. You can't displace with the same map both out and in. This displacement map describes veins and muscle striations in the chest area across the arm. Again, to see the effects of the displacement map, you have to enable the mental ray renderer. Here the displacement map has been combined with a color map with standard roughness, or just a little breakup of the surface. Then you can see the effects of the displacement bumping out. Again, if you want it to displace inward as well, the opposite direction of the first displacement map, you would need to add a second displacement map. We can just click on the next button, load a new texture in, and this time we can have it bump the other direction. A negative roughness. So now the checks texture bumps in, cuts into the shape of the arm, while the veins texture still bumps out. You can see right here that we would need to tweak the surface approximation settings just a little bit to get a perfectly smooth result. Displacement maps are really very powerful. You can do things like put a wrinkle texture on this NURB shirt very quickly. The thing you have to watch out for with displacement maps is how adjacent objects can intersect with the displaced portion of the model. For instance, here these straps are very close to the shirt. In the shaded mode it looks fine, but in the previewed or rendered picture you can see the problem with the intersection right here. With displacement maps it's a little difficult to solve those kinds of problems because you can't see it in the shaded mode. There's no interactive preview, and you just have to keep previewing over and over after tweaking the settings. Those are the issues that are particular to a specific geometry type. Now we'll move on and talk about materials. When dealing with materials in Softimage, remember that each one of these channels here on the left, the ambient, diffuse, and the specular, can each be overridden by other factors in the scene. For instance, if we crank up the lightness of this ambience, you see in here, in the preview window, it's still dark. Even if we bring it all the way up to pure white, it's still dark. Of course, the reason for that is, if we go into Atmosphere Ambience, you'll see that I've zeroed it out, each of the channels to 0. So all ambient area, or all the area where light isn't striking, is pure black. If we raise that up, you'll see how the material will begin to take effect. If we go back to the material box, you see that's reflected in the preview. Same goes for the diffuse. We can put whatever color we want in here as long as the texture's blending is set to 1. So we can make him purple, and he can appear purple in the interface, but upon the preview he'll look normal. No purple there. Most of the time I keep the ambient black and the diffuse color near the color of the texture map just for convenience sake, but you don't have to. As far as the specular color is concerned, you may not find that you are always using a specular texture map just to describe the specular areas. So this one it's useful to pay attention to for the material. Most of the time for most materials you want to keep this low, but remember that a slight roughness in the texture map will break it up a bit, so you can keep it a little bit higher than you might think. But still, I tend to keep the values very low, in this case for the skin about at 1.5. You can certainly add a little color into the specular highlight. Sometimes a contrasting color works nice, very subtle. And again, this can be covered by the texture map as well. Now as far as the specular decay is concerned, most of the time you're going to want this flat or broad. You can dial it up for very shiny objects, or type in a very high value for extremely high specular decay. For this value, there's no texture map component that will override it, so this tends to be an important value. For the reflectivity or transparency of an object, if you wanted to go over the whole object, again, you would use these channels to describe that. But they can also be overridden in the texture dialog, so you can have reflectivity or transparency based upon a certain texture map that you define. When you want to share a material, you can use one of the several methods. In Character Kit 1 we talked about just having the parent of multiple objects have a material and or a texture, and of course all the children objects, if they don't have their own, will inherit the texture and the material of the parent. So you can arrange a hierarchy to simplify texturing this way. But let's say for one of the teeth you don't want the same texture map on it. Well, in that case, if you put a different texture map on it, you'll also need a different material. If you want to start from the material of the first tooth, then you'd need to copy. All these lower teeth are in their own hierarchy. So let's say we wanted to take this tooth right here, copy the texture from this tooth onto it, and start with, like I said, the material from it. We could go to Material Operation, Copy Mat, then click on it, the other object, either in the interface or in the schematic view. The other tooth gains the new texture, and we can modify that, or we can now add a texture map. We'll also copy the texture map from that other tooth, and then we'll go ahead and modify it. This way we can introduce an offset into the texture map value, or decrease the roughness, change things a bit to break up the sameness of the texturing. The reason why this is an important material issue is because if we do the same thing without copying a material over, we'll get just the default material. Now I've copied the same material onto the third tooth there. If we ever wanted to change these materials, we have 3 discrete materials to deal with. So to get these to be the exact same material, to all update the same, and this only works for global materials, not local materials like you can do with polygons, we can do an optimize command. Material operation optimize all will take every material in the scene and try to optimize it. This can lead to trouble though, and so I recommend against using that. Instead, grab each one of the materials by hand, then we can use the optimize selected. They all join into one material. Now whenever we edit this one material, of course, it will update in all 3 of the teeth. Now if you ever need to discontinue that relationship and have a separate material for a particular tooth, the easiest way to do that is to get the material and then delete. This will essentially disassociate it from the material, which as you can see is still there and is still associated to the other 2 teeth. This is a bit faster than going through the material operation disassociate command and then clicking on the material icon. Also, the equivalent of copying the material and then optimizing the selected is to go to material operation associate, similar to that disassociate command, where we just click on the material icon and that object is also associated then with that material. To begin texturing the shirt sleeve object, I'm going to frame it and then go into Texture 2D Global to assign a new 2D texture. I'm going to select a sleeve texture. If we look at it in the crop dialog, we can see that it's a fabric texture going basically in a grid format. This will flow nicely over the NURBS. These are the default settings, with blending set all the way up and ambient to 7.5, diffuse to 1, no specular. Blending will control the strength of all the channels except for roughness, so if we turn down blending, it doesn't matter how high we have any of these values. The overall blending will dial them all down. It's not the case, however, with roughness. We can turn roughness up a bit, and if we do a preview, you can see that the roughness is still on there, even though all the other properties have been dialed down. With overall blending, normally you want this to be at 1. If we turn up the diffuse a bit, we can see that the overall blending will blend the color of the map with the color of the material. The diffuse property says how much of the color map should show on the diffuse areas of the model. Ambient is the same for the ambient parts of the model, but since global ambience has turned off, the ambient channel has no effect. Specular is often off. In order to have an effective specular map, most of the time you'd want a separate map, and I'll show that in a minute. This blending section here by default is controlled without mask. In other words, the intensity is the same regardless of the colors of the map. We can also switch to RGB intensity. You can see it decreases in intensity because the closer to black they get, the more the map will disappear. You can see the difference between those two. With the alpha channel option, you can have the alpha channel of the picture determine how much of the map shows through. I'll use this fish picture as an example. Let's make a new channel in Photoshop just by clicking down here. Then we can copy and paste a picture into the alpha channel. We can modify it. What we want is for the background to be black and the fish to be white. We can also make the edges of the fins gray so that they can be translucent. Save it as a pic file and then load it into Softimage here. Now if we go into the blending alpha channel mask option, you see that the alpha channel will clip all the parts of the texture map that are outside of the fish image. We can scale and translate our texture map onto a part of the model, and you see how the image is now overlaid onto the arm. So you can overlay over a material, but you can also do it over other textures. So if I click the previous button, I've loaded in a texture here. If we do a preview, you can see how the fish is now overlaid over the texture as well as the material. Now I'll turn that off. Over here, normally, the transparency, the reflectivity, or the roughness is affected by the normal colors of the map. But you can also turn alpha channel on over here, so that instead of the colors of the normal channels, it's affected by the alpha channel. So if we go to transparency -1 now, you see that the alpha channel pixels that were dark are now transparent. In this case, it doesn't make it transparent over the other textures, but it makes the actual object disappear in those sections. If we go to -1, we can make the fish area disappear and the rest be visible. To clip out an area, we could change the blending so that the ambient was off and the diffuse was off, and only the material would show. Here we can choose the mapping method. Of course, NURBS have the built-in UVs, but also you can choose one of the projection types, the XY, XZ, the YZ, and the planar types, which look great from one direction but then stretch along the sides. Or with the cylindrical, which you can rotate into place and will look good from most angles, but in areas that are perpendicular to the projection that will stretch. And of course, spherical. Unfortunately, rotating a UV texture has no effect, but with each of the mapping types you can scale or offset it in the interface or in this dialog here, or only in the dialog you can set it to repeat a certain amount of times. Now we'll look at some examples of detailed texturing. First thing to do if it's a NURBS is to make sure that the edge flags are arranged properly. So here you'd want the green to be the bottom of the texture map and the red going up the side. So that looks alright. Next thing you might want to do is to apply a checkered texture to it. Use the same mapping method that you're going to use in the final texture, in this case UV. This will help us to see if the parameterization of the NURBS object is workable. The goal here is to get the checks as square as possible and not to stretch. The other thing to notice is that the checks are squashing in this direction, so we would need a map that was longer than it is wide. If I go back into the texture dialog and repeat one time in V, you can see that the checks are now a little bit more square. This lets me know that I need a map that's almost 2 times as tall as it is wide. Next we'll make a new map to place our texture. You might want to start big, you can always res down. So I've made it 600 by 1000. We'll name it, write it out to pick format, and then load it onto the arm. We'll make sure to turn off the repeats in U. To texture the hand on the arm, I'm going to use some real-world textures. This is just my hand laid on a scanner. We can begin now to copy chunks from this onto our object. If you don't have access to a 3D paint program, you can use Softimage's paint, but it does have certain drawbacks. For instance, even if I select the whole hierarchy and click on paint, it'll only load up the arm. And so we won't be able to paint a connection area between the thumb and the fingers. Well, one thing we can do is mark up different areas for reference for painting in a true paint program, and draw on areas of the hand to give myself an idea in the paint program where things are. So these are where the 4 knuckles will be located, for instance. I use 4D Paint with Softimage. 4D Paint has a plugin that allows you to just grab some objects in Softimage, hit Texture, 4D Paint, and it automatically loads those objects with all their correct mapping types in there, including UV. From here we can begin copying and pasting areas of the texture map onto the hand from Photoshop. I'll go to Photoshop, select the map, copy, hit paste in here. You can see that it's too big, so I'm going to scale it down. I'm going to then flip it vertically and horizontally, and you can see now it's basically lined up with the thumb. There's that first knuckle of the hand. I'll just place it right there. When I'm done, I'll hit Drop Floater. Next I'll create a new color layer so that the next selection can be irregular and I can erase off the excess portions. I'll go back to Photoshop and grab the next portion of the hand. Again, we need to scale it down, flip it in 2 directions, and then arrange it. We can also rotate if we need to get it positioned properly. Once I have it positioned right, I'm going to drop Floater. Then I'll take the eraser, I'll go to a hard brush. Now I'll erase off portions of the texture map where it overlapped with the other one. When I'm satisfied with the 2 texture maps meshing, I'll just hit the Layers, Collapse All. I'll continue taking sections of the hand and pasting them in to 4D Paint and arranging them. Continue this process for the other side of the hand and up the arm. 4D Paint is better for placing existing textures than actually painting them, so we'll do a lot of cleanup in Photoshop afterwards. When we're done, we hit the Output button and go. 4D Paint then automatically loads the texture maps back into Softimage onto the arm. When I load the texture map back into Photoshop, it looks like this. I can use the clone feature to clean up areas where the connections are. Continue on with this process until your texture map looks complete. So that looks pretty good. But what if you want a texture to appear seamless across multiple objects? To show that, I'm going to get this hand, which has been more seamlessly connected using Quick Blend. This is the beast hand shown earlier, and you can see close up it has a pretty good connection using Quick Blend. I've placed a texture map on each of these fingers and the hand, so I'll just multi-select those, go back into 4D Paint. Now I'll do the same thing as last time. I'll copy a texture from Photoshop and paste it on the hand in 4D Paint. Sometimes you'll have this problem where I want to position a little bit higher, but instead it goes on the finger. You can go into the objects and start to hide some of the fingers so that doesn't happen. Now I'll grab the same texture but a little bit smaller, and I'm going to paste it onto the finger. The trick here is to try to match up the texture exactly as close as possible. Again, sometimes you'll need to hide certain fingers. The texture was a little bit too big, and so I couldn't place it quite right, so I'll make it a little smaller and try again. Sometimes you'll need to scale as well in one direction. And that looks like a pretty good match. Back in Softimage, we'll see how it all worked out. Do a preview all. And it looks quite good. You can use this approach to make detailed, textured characters that withstand close scrutiny. Here's an example of a hand that I completed using that exact same method, only this time I used also bump maps in addition to the color map. You could make out edges a little bit in the Softimage renderer, but in Mental Ray it looks a little bit better. All in all, a very solid approach to multi-surface texturing. If you're going to be texturing a polygon object that already has MetaMesh applied, for instance here we can see the wireframe laid over the smooth version, in the schematic window you can see how they both point to the same materials and they both share the same textures. This is because they're using local textures instead of global textures. This makes it a bit easier in the texturing process because we can then select the high-res head and then do all the texturing on that, and we can still preview that high-res head. And the changes will automatically reflect on the low-res one so that when we change resolutions they won't disappear. So that means it's a bit easier to use local textures than global textures. With the high-res head selected, we'll go into Texture 2D Local, and you can see the textures that have been applied to the head. First off is a color map that looks like this. This is created similar to the hand and the fingers shown earlier. Photographs of faces were cut and pasted onto the model of the head and then cleaned up afterwards in Photoshop. The color map was applied with full overall blending and then the diffuse channel all the way up, so it would look like this on the model. No ambient and no specular were used, and no roughness were used since these were handled by other maps. If I click on Next, you can see the specular map that was used. Areas that were brighter on the specular map are shinier. This map was made by simply painting a regular color map in 4D Paint and then afterwards using that map in the specular channel only in Softimage. You can see that the specular channel is all the way up and all the other channels are off. The next texture map was applied only to the roughness channel. No ambient, no diffuse, no specular, and the roughness was set at -5. The map doesn't show with the On Material view mode selected, but in entire we can see it. This map began as a grayscale duplicate of the color map, but then was enhanced and added to. Bumps were added in certain areas like the nose and the forehead and the cheeks to add some complexion. The eyebrows were inversed so that the white parts would stick out, and those parts were sharpened. The lips were replaced entirely by a new texture map which emphasized the bump on the lips. If we had the low-res MetaMesh head selected, then this preview button wouldn't do anything. MetaMesh automatically doesn't render the low-res version and swaps it out for the high-res one in a full scene render, but since we're texturing the high-res version, we we can always do a preview of the smoothed one. When texturing faces, it's a good idea to have an animation, at least a test animation, that shows the mouth, for instance, in different positions. This means that when you do previews, you can see somewhat the inside of the mouth. If you want to frame part of the mouth to work on it, you can use camera frame tag. But when you use MetaMesh, the object is ghosted and camera frame tag doesn't work. You have to first unghost the model, then run camera frame tag for it to work. Layering a few simple texture maps like that can really go a long way in making your surfaces look convincing. Earlier I mentioned how you can select a group of polygons and apply a different material to that group. You can also use it as a holder for 2D textures. You can apply the same material on it and then limit the 2D texture to just that group of polygons. Here I have this front side of the shirt polygon selected. This portion of our polygon model can now receive a texture map that's solely designed for that region. It makes sense to divide up the polygon object this way for the mapping types, because as you can imagine, the cloth texture that will go on this shirt won't be able to wrap on both the arm cylindrically and the front and the back without stretching. Make sure you first apply a global material, and then with the polygon selected again, you go into Polygon, Assign New Material. If you want to use the same material on each portion of the shirt, you could save this configuration out under a name. For instance, we can type shirt and then save it out. When we then make our next selection and use Polygon, Assign New Material, instead of using the default, we can search for that same material. This way the color and the specular values will remain the same on each segment. Once you have multiple material regions defined, you can switch between them with Polygon Previous Material and Polygon Next Material. Feel free to set your own hotkeys so that you can quickly toggle through the materials back and forth. If you find that you made a mistake in the polygon selection, for instance if you decide that these polygons right here should be assigned not to the sleeve but to the shirt object, you can use the Polygon Assign Current Material command. But be aware that this command works only in additive mode. You can't remove polygons from the selection and then use Assign Current Material. You need to switch to the material you want to add them to, then add them to the selection, then choose Polygon Assign Current Material. Then when we switch the sleeve region, you can see that the proper polygons have been deselected. Of course, don't be fooled by polygons like these, which are merely non-planar, and so they appear to not be selected. You can tell that they are selected in the wireframe mode. With the region selected, you can then go to Texture 2D Local, then apply a new texture. Either a cylindrical or a planar projection will look great from certain angles, but from others like the top or the sides it will stretch. Also, local 2D textures are automatically applied to the whole object regardless of the polygon selection. So we've selected only this half of the shirt, but yet the texture stretches over the length of the whole object. We need to crop that by scaling it down and then translating it over. Softimage allows you to convert any projection texture to a UV texture for polygons. Once it's converted, you can go into the Paint dialog and edit those UVs however you like. Holding down Shift and G, click anywhere on the model in this window. All the polygons will highlight, and then when you choose Show UV, the UV handles appear in this window. As you drag those using the M key, you can see that you can make changes to the positioning of the texture map on the polygon object. Using the G key, you can select and deselect individual polygons as well. While it's a great tool for very low-res polygon objects, for objects like this, it's not very practical. If I select all the polygons in here, you can get an idea of the mess it can be. In order to fix up this side stretching area over there, you would need to zoom in and pull apart each of these vertices, and it's very difficult to tell which is the edge. You can select certain ones with tag and move them, but again, it's difficult to tell what's what. Here at Cineframe, we designed a plugin called UMAP to address this problem. Using UMAP, you can construct a NURBS object that surrounds the polygon object, either in whole or in part. For instance, we could turn on Magnet on Point All Visible Objects, and then draw a NURBS curve, starting at the bottom of the shirt. We can duplicate the curve and move it up, and then magnet the points to different parts of the shirt object. When we're done, we'll skim these curves together, The object we'll make is called the guide object because it will guide the UVs of the polygon to flow however we like over the surface. Since the texture map will be a rectangular area but the material selection is irregular, we'll just let the edge points hang off the side. When we're done, we can move the points around to better fit this front shirt area. And we can add rows as needed. The UMap plugin will now automatically transfer the UVs in real time from the NURBS object to the polygon object, so we can get a smooth, tight-fitting texture on the polygons. First, go to Matter mode in the schematic window, select the shirt object, and then make sure that you can see the local 2D local texture. In Matter mode, we can choose Texture Operation UMap. Click on this object, the guide object. Sometimes it's hard to pick since it's so close to the other object. Then pick the 2D local texture, and then the polygon model. You can leave the values at the defaults and click OK. UMap automatically switches the texture type to UV, then arranges the UVs of the polygon object to match those of the guide object. So rather than being projected from a certain angle, now the texture wraps tightly around all the angles of the polygon object. As we move the points on the guide object, the UVs of the polygon automatically update. Just like texturing the arm before, sometimes it's easier to tell what's going on if you apply a simple grid texture to the object. You can see how the changes in the NURBS are automatically inherited by the polygon object. As another example, I'll show this boot object here. We'll just apply UMap just like before. First, select the NURBS, the texture, then the polygon. And you can see the texture will reform according to the NURBS. As with all persistent Softimage custom effects, it has an icon associated with it. It's hidden underneath here. If we select Info Custom Effect, we can take a look at the parameters. First is the NURBS oversamples. You can see on this side of the boot that some errors have been created. This is because there aren't quite enough NURBS curves on this side, so as the vertex goes out to find the closest UV value, it encounters troubles. We can easily solve this by increasing the number of the NURBS oversamples. This effectively subdivides the NURBS guide object during the calculations. Iterations increases the accuracy from the polygon vertices side. As we increase these numbers, the effect can get slow, and so if you want to keep the relationship but turn it temporarily off, we can use this. If you don't want to create a relation at all, you can just turn off this value right here. Increasing the NURBS oversamples to 2 took care of the problems in this area right here. Then I had to go to 3 to take care of some problems in the front. Alternatively, we could have just had a slightly higher resolution NURBS guide object. Using UMap, you can even do tricky areas like this, where the texture actually curves over the boot, rather than projecting through the boot. Once we're satisfied with the placement, we could just delete the icon to freeze the effect. Now we can hide or delete the guide object, but we should keep it on file in case we ever need to reuse it. Of course, the boot will render fine without the effect. The UV values are stored just as they normally would be, and you can see those in the paint dialog. We can make a different guide object for each section of the shirt. Most of the time you want these ghosted so that you can see them hovering over the polygon geometry. Using UMap like this, I was able to apply a different texture to each section of the shirt. Even at close-ups, the thread pattern follows the shape of the shirt. UMap was also used on the head object. This helps especially with areas like underneath the chin. Rather than stretching from the cylindrical projection, it can flow nicely. The texture can stick perpendicular to the surface at all times. Helps with areas like the inside of the mouth, under the nose, especially around the ear. I simply dragged the guide object around the ear so the texture wouldn't repeat from the ear to the back side of the head and stretch along that area. This worked pretty well, but note that I also could have had a separate cylindrical guide object for the ear alone that wrapped more closely around the ear. This would have required a separate material, of course, for the ear, but this approach turned out to be much easier and provided the control I needed. That's one of the benefits of UMap. You can decide how to arrange the texture map on your objects. So for instance, rather than a cylindrical texture going down this claw, and then having one for each of the claw fingers and the back, I simply use UMap on this object on only 2 separate materials. One covered the bottom, and then one covered the top. The texture map was arranged cylindrically around and then spread out over each of the claws, but it was much simpler than breaking the texture map into 5 different pieces, and then making a seamless texture map connection in each case. You could think of render map as the opposite of UMap. UMap alters the actual UVs of an object. Render map stretches the texture to match the UVs. Render map is a real versatile tool that actually ray traces out from the surface to the scene. You can use it to do things like convert projection textures to UV textures. You can use it to do things like rendering the lighting effects onto the texture map. In our case, we're going to use it to convert a 3D procedural texture to individual UV textures for each one of these fingers in the hand. To start off, notice that the hand has lots of quick blend effects assigned to it. So we'll use this hand as the receiving hand. Since we want to keep this quick blended hand and all its relationships, the one that we duplicate will be the one the textures are projected from. That'll be the one that we apply the procedural textures to. So we'll just do a duplicate immediate. We'll just go ahead and delete all these textures and materials. Next, I'll just hide the original hand. On this one, we'll place the 3D texture, Texture, 3D Global. I'll switch to a cloud layout and scale it up a bit. I'm applying the global 3D texture to just the hand object, but that gets propagated down to all the fingers. 3D textures don't follow the shape of an object. It's just like a cloud that the object sits in. The drawback to that is, in Softimage, you can't lock the 3D texture down. So in envelope deformations, the object will pass through the 3D texture as if it were a cloud. So here's my finished 3D texture. I'll just change the material. That'll look better. Because of the cloud-like nature of the 3D texture, it'll always appear seamless across multiple objects. So on the right we have the hand with a 3D texture. We'll need to change its material again to be constant. This way, as render map ray traces from the surface of the other hand, it won't take any of the lighting into account when it creates the texture information. I'll temporarily hide the hand on the right. For the original hand, we'll need to apply a 2D local texture to each of these objects. It needs to be a separate texture, of course. Texture, 2D local. It doesn't matter what the contents of the picture are. That won't be used. Only the size of the map matters, and the mapping method. We want to use UV in this case. The material method in this object doesn't matter, but render map, when it does its job, will switch it to constant and we'll need to switch it back. Next, we want to hide everything in the scene that we don't want it to see when it's doing its render map calculations. We'll hide that hand and unhide the 3D procedural hand. Next, we'll do texture operation render map. Then we want to pick one of the 2D local textures, in this case the one of the parent, which is the hand. In the render map dialog, turn off use texture. And then for the picture name, we can leave it at the default. It takes the file name and then adds an underscore light to it. We'll click OK. Render map will take a minute beginning the render, then it'll actually render the frame, again ray tracing out from the surface itself. When it's done, we'll grab the hand object, unhide it, and then do a quick preview. Render map works best in areas where it doesn't get a little concave, like the inside area of this palm here doesn't look quite as good as the rest. We'll need to hide that again, and then continue on for each one of the fingers and the thumb over here. When we're done, render map will have changed all the materials on this hand to be constant. We'll need to switch all of those back to Lambert or Phong. An easy way to do that is to go into the spreadsheet and then click on Matter General. You can see the type of shading used here. If I just left click and drag, I can select all those, middle click on any one of them, and then type in something like Phong in capital letters. When I hit enter, they're all switched to Phong. Of course, we want to hide the 3D procedural hand now. We don't need that. And when I preview that, we can see the result. So it looks pretty seamless. If we take a look at the actual thumb texture now, for instance, render map will stretch the texture however it needs to look just like the 3D texture. Now we can actually make use of this texture. If we put a skeleton in the hand and animate it, instead of the objects passing through the 3D texture, they'll stick to the surface like they should. I used to take a simplistic approach to doing eyes. I applied a single texture with the iris, the pupil, and the whites projected down this direction. And when rendered, it looked glossy enough, but the pupil doesn't look shifted back at all. In fact, because of the bump, it even looks a little bit set out. The iris should be just a little bit brighter underneath, and often there's a shadow cast, from the eyebrow onto the top of the iris. With this approach, the more you see the eyeball from the side, the less convincing it is. The whole texture just looks like it's plastered on. The pupil isn't set back at all, and it's not a very convincing effect. This approach, on the other hand, tries to mimic the actual structure of the eyeball. With this approach, the iris actually does look concave. The pupil is inset, and the iris looks brighter on the bottom. There's a highlight on the corneal bulge like in the other setup, but the overall effect is much more realistic. Now again, to get this effect in 3D, we just need to mimic the actual structure of the eyeball. 2D global texture is applied to a sphere that looks like this. Just away from the pupil it begins to turn red. The texture map also has an alpha channel, which clips out the section where the iris is. Rendered by itself, the eyeball looks like this. The iris area is cut out and you can see to the inside of the eye. The alpha channel is a little bit blurry, so the transparency isn't too harsh. Next, an iris object is placed inside of the eye, like this. It's positioned just in the same place where the iris is clipped out of the eyeball. Looks like this all by itself. And then right behind this is a constant shaded, very dark object to simulate the inside of the eye. Putting these three together, it looks pretty good, but there's no glossiness to the eye. We can't apply the glossy material to this object alone, because the clip map makes that entire part of the object disappear. To simulate that, we get a second spherical object that encompasses roughly the same area, is a little bit larger. On this object we place another texture map, which simulates the corneal bulge. It's just a black and white texture that bulges up in roughness. For the material for this object, we put the specular decay very high, 500, place a little bit of reflectivity, quite a bit of transparency, almost completely transparent, and then a refractive index just above 1. The refractivity will help the iris look like it's bent by the lens in the eye. When we look at the eye a little bit from the side, you can see how the pupil is inset, but the iris also looks like it's refracted. The outer sphere has all the highlights on it, and in the area of the corneal bulge, the shiny highlight is catching that shape. The iris object itself could also be shape animated, so the pupil could appear to dilate. To finish it off, I've extracted two NURBS curves from the eyeball. They're arranged just about where the iris is, so I can tell where the eyeball is looking. So this approach to texturing eyes gives a much better result. There's still no hair plugin for Softimage that will allow you to do full heads of hair, defining each strand. But you can enhance the sort of helmet method that I showed in Character Kit 1 by adding on overlaying objects. Here we have some strands coming out of the hair, coming off of the hair, and then some objects overlaying the hair. Each of these texture maps, of course, will have more or less straight hair, and then also an alpha channel mask, which will make the object disappear along the edges of the hair. Of course, it's not just for the ends of the hair, also for the roots of the hair. You can use that alpha channel to make it come out and look like they're individual strands. There's no way we can get it to look perfect from all angles, but the idea is to soften the effect, to make it look a little less hard and CG. I used this technique successfully on this ring of hairs or tiny feathers. This parent object, we'll take a look at its texture. The texture looked like this. It was a scan from an actual white, furry-looking feather. An alpha channel was also applied to mask out the feathers. Pure white will remain opaque, and black will be transparent, and then lots of grays are used to make a subtle transparent effect. The transparency map component was set to -1, and other than that, it was pretty normally applied. For the most part, I let this texture cascade down the hierarchy, but most of them had that very same texture. If you take a look at how these are layered, it's pretty simple, but there are lots of layers used to enhance the illusion. When I preview it looks like this. It looks a little bit like fine feathers, but in some areas it's obvious that it's made out of individual 3D shapes. Especially from the back, you can see those individual rings of the geometry. It really spoils the effect. To soften that effect, and hide the fact that they're made up of individual geometry, a static blur was applied with a very small width and a decay of 2.4. The ambient was set at full white and the diffuse at full white as well. With the static blur on, the effect is softened all around. As it blurs the actual edges of the 3D geometry, the overall fur or feather effect looks more convincing and soft. With the static blur applied, you can even look from the back into the sides of the 3D geometry, and it still looks basically furry and soft. Each individual ring of hair by itself is not very impressive, and the combination of the alpha channel and the static blur make each layer very transparent. So you have to use very many objects layered together to make it look right. So even though there's still no perfect solution for doing hair in Softimage, you can use these tricks and methods to fake hair pretty well. All the material and texture parameters in Softimage 3D have accessible function curves. This is useful not only for animating them, but also for linking them together via expressions. We can place an expression on any material or texture in Softimage. First we need to go into the schematic view, turn on the matter mode. Instead of selecting the object, we want to select one of these nodes to place an expression on. In this case, we'll choose the material associated with this part of the shirt, grab the material, and then go into Expressions Edit. But before we do that, we're going to need to create an object to relate the expression to. So I'll go into Get Primitive Null, and then we'll grab the material and go into the Expressions dialog box. First I'll scroll over here and make sure the cursor is right after the dot. When I click on function curves, I'll get very different function curves to deal with than you would for any normal object. Since we've selected the material, we get all the material properties. We have the ambient red, green, and blue, the diffuse red, green, and blue, specular red, green, and blue, specular decay, reflectivity, and so on. In this case, we're going to choose the diffuse red. Click over here, then I'll go into Scene Elements and relate it to the null that we just made. For its function curve, we'll choose something simple like its translation in Y. So that looks alright. I'll click OK. Immediately that part of the shirt changes color. Since the null is at Y equals 0, there is absolutely no red in the color mixed. As we drag it up, the amount of red will increase. Now let's look at the function curves we get for the textures. We go into Expressions Edit, and then F curves. See what we have: the U scale, the V scale, U and V offset, the blending, ambient, diffuse, specular, transparency, reflective, and roughness. With the roughness, we can do some interesting things. Access to the roughness F curve allows us to do things like animate the folds or wrinkles in clothing, or the wrinkles of a face or on an eyebrow. Let's add automated wrinkles to this character's eyebrows. First we need to paint them on. I'll make a duplicate of the head. I'll add a new texture using the same UV coordinates as the other three. It's a bump map specifically for the forehead, but I won't add any roughness yet. Next I'll delete all the other textures. So I have only this one texture on. I'll delete the textures off of the hair. Then I'll do Texture 4D Paint. Bringing the hair in too will allow me to get a better sense of the distances and where to place the wrinkles. Now I'll paint in the wrinkles dark so they'll bump down. Now that I have the placement worked out, I'll go back into Softimage and then clean up the texture in Photoshop. Now I'll blur and clean up the wrinkles, and then remove all the other detail from the texture map. I only included it so I would have some reference while painting. Next I'll apply the finished texture map to the original head using the same UV coordinates again. Next I'll do a quick preview to make sure it's basically working. This is at a value of -4 roughness, so I'll want to keep that in mind when I'm working with the expressions. Just like before, I'll get a new null, then I'll switch to motion module. Here's the head object and the associated material. Here are the textures. This is our new wrinkle texture, so I'll click on Expressions Edit. I'll choose the roughness channel and relate it to our new null. Click OK. Now as I drag the null up and down, the roughness value will change. Of course, to see that it's not interactive with the view, I'll have to preview each time. So far so good. This is with the null dragged down to about -1.5. We can also verify the fact that our null slider is working by simply dragging it up and down, and then we can see that the value is -3.5. We can select the head and go into 2D local texture, and we see that the roughness value is the same. Now we can go one step further. We can relate the roughness value to the shape animation of the face. First we need to find the shape animation of the eyebrow lift. So I'll select the head and go into Shape, Shape List, and then click on it until I find the one that has the eyebrow lift. That's shape number 14. Next I'll select the texture icon and go into Expressions Edit. I'll take out the null reference and replace it with the head. Rather than the head's translation in Y, we'll equate it to the shape animation of the head. We'll go into F curves and select the weighted shape number 14. Now I'll step through the frames. When the shape animation is at full strength, the roughness value will be at 1. We want it to be at -4 at full strength, so we need to change our expression. Again, I'll select the texture icon. First, I'll multiply this value by 4. This will mean we'll get a +4 when the shape is at full strength. And then since I want a negative, I'll negate this by multiplying this by -1. Shown visually when we turn on Show Controls, you can see it's represented by a circle around the beginning of the joints. And also we can have some control over the shape of the bicep if we select that first joint and go into Skin, Deformation Parameters, Inner Side. We can tell it to bulge like a bicep. And then as the arm joints are rotated, the bicep will bulge a bit. Those are simple levels of control you can have over the deformation in the joint area. But many times, because the model is a bulky superhero, or a burly or a fat character, the areas around the joint won't mash together nicely as they press up against each other like they do in reality, but instead they'll intersect in an ugly way like this. If we select the joint, unfortunately the joint area parameter won't help us at all, because by the time we get to this area where the vertices which are overlapping will be affected, then our knee looks ugly. So we have to leave this number very low and try to solve the problem a different way. Instead, we can use shape or cluster animation to determine just how the joint area will look. So to do that, we'll go back a few frames, do Save Key Object Shape. We'll go ahead to the frame where the leg really starts to intersect. We'll just begin to manually move points and fix the area that's intersecting. Of course, the other side needs a lot of fix-up as well. If you do make a mistake and have to use undo, luckily the undo won't change all of the shape back to its state. You can do undo once and it'll undo that last move without refreshing the whole scene and thus losing your changes. Since you've applied a shape animation, any refresh of the scene